Another thing that you should learn before calling yourself software developer and asking questions that are basic, that show how little you understand about software, is the distance of the software of your code to the machine. This is being native. So there is two ways a program is executed. Either it is compiled or it is interpreted. Compiled means your software, the code, is packaged optimally, and doesn't before it starts, it does not. It is packaged to be executed directly, and this increases the building time by compiling, by packaging your text to package that is executable. But this makes apps slower to code. The other way is interpreted languages like PHP, like Python, and JavaScript, the most popular and most used language, JavaScript. So every time an application runs, it is re-scanned, parsed again and again for each execution, and this makes it slower and purely from architectural viewpoint. This makes the program slower. But let me tell you about several layers between these main two. So the closest to the machine is the machine code. It is the code that is compiled for the architecture, for the chip. So the chip providers have specifications of how they move the bytes, and when a small layer above the chip software layer is using them, the software starts using the chip optimally with the best performance in mind by using the specialized instructions that the chip maker provides. And this is the optimal way, by using the concrete stuff that the chip makers provide. But this is not optimal for software development, because there are many chip makers and they all provide different types of instructions. So to make software faster, over the years there has been made a structure, a way to distance the source code to the from the machine, from the hardware, from the iron. So in the past, the C language and BASIC and the C language moved away, lifted the level of distance to the hardware by hiding a lot of complexity, like addresses in the memory and so on. So languages like C and C++ are compiled and executed natively. But to make developing new languages faster, there is a tendency of making compiler infrastructure, LLVM. It is specification of, it is C-like specification of how the program, basic programming manual that is a computational minimum that is managing memory stuff and variable allocation. So this is a infrastructure for compilers. So if compilers implement these specifications, they could write higher level programming languages that when they go through a compiler that has implemented this LLVM, it will compile closely to native. LLVM, low-level machine virtual machines, are probably not designed to use all the best instructions from the chip makers, but they are because they are compiler infrastructure, their performance is actually good one, because these are recommendations for compilers. The compilers are the programs that transform your source code to native package. So the above layer, after the low-level virtual machine, are the virtual machines like Java and C#, and there are several others that are designed to when you program your apps on them, you program on yet another level above the hardware and above the software. So they give you primitives like the window that you use. They give you primitives like streams of bytes and probably many more abstractions that are more closer to the human mind and to the human idea of processing stuff, and they take care of how it is implemented on the intermedium and into the lower layer of the machine. So these are next level. These are the next level, and to make them more optimal, there are so Java and C# in their general case are just-in-time compilers. You code your programs in these abstractions and just in time, not exactly interpreted, because your programs are instructions, but they are closer to JIT, just in time, are somewhere in the middle between interpreted and compiled. But there is something else called ahead of execution, ahead of time compiling, that transform these just-in-time programs to compiled, and they do what the just-in-time virtual machine executes, and it executes it before going to the execution phase. So here you have machine code, low-level virtual machine, ahead of time compiled code, just-in-time execution, and runtime interpreting of code. So this is a way of separating the ideas that you program. So the closer a thing is to the human mind, probably most likely it is layered above the how the chip works. So you don't think about how the bytes go from the hard drive to the RAM to to the CPU and mathematical operations. Instead of thinking about this all about stuff, you think in terms of voice, in terms of pictures, in terms of videos, in terms of windows and drawing stuff. So this is the power of going higher level. So I hope this minimum level of knowledge how the machine works helps you. And when you grab some technology, you should know in what layer it does. So do not ask stupid questions on basic programming stuff that you haven't learned.